Hello, in this video we're going to figure out the rules regarding the calculation of the resultant uncertainty. So let's have two measurements, A with an uncertainty of delta A and B with an uncertainty of delta B. If we are calculating X equals to A plus B, what would the resultant uncertainty be? Okay, I think everybody knows this one. It's just delta A plus delta B. Now what if we are doing X equals to A minus B instead? Then delta X is going to be delta A, not minus, it's still plus delta B. So how is that possible? Reason is this. If you are going for the maximum value of X, then you are going to arrange for the maximum value of A minus away the minimum value of B, isn't it? And for the minimum value of X, you are going to arrange for the minimum value of A to minus with the maximum value of B. So you see, we are going after the worst case scenario. So we can always arrange the signs of our delta A and delta B such that we end up summing up delta A with delta B. So it doesn't matter whether you are doing A plus B or whether you are doing A minus B, the uncertainties always add up. Okay, now what if we are doing X equals to 2A minus half B? I think this one is quite intuitive. So delta X is going to be 2 times of delta A minus half of delta B. Yeah, so the coefficients act like the scaling factors that will scale up the uncertainties. Okay, let's move on. What if we are doing X equals to A times B instead? So now we are multiplying up terms. So if you have watched the previous video, then you know that this time round is the percentage uncertainties that sum up. So what if we are doing X equals to A divided by B instead? So now the percentage uncertainty of X comes from the percentage uncertainty of A plus the percentage uncertainty of B. So again, it doesn't matter whether you are multiplying or whether you are dividing, the percentage uncertainties always add up. Because we can always arrange for the maximum value of X, and we'll get that from the maximum value of X divided by the minimum value of B. Yeah, and vice versa for the minimum X. So it doesn't matter whether you are multiplying or dividing, you always sum up the uncertainties. Okay, what shall we do next? Let's try X equals to 3A divided by B. So the percentage uncertainty of X is now going to be still the same. The percentage uncertainties of A plus the percentage uncertainty of B. There's no change. The 3 here has no effect. Why is that so? Now, one way to think about it is to see as we got to sum up the percentage uncertainty of 3 also. But what's the percentage uncertainty of 3? It's equal to 0, isn't it? Because 3 is not a measured 3, it's a perfect 3, which has no uncertainty associated with it at all. So this one way of looking at it. The other way of looking at it is to realize that the coefficient 3 is going to scale up the absolute uncertainty delta X by 3. It's also going to scale up the value of X itself by 3. So again, this will cancel each other out. So that's why a coefficient, when we are summing up percentage uncertainties, is irrelevant. You must ignore it. So what is going to scale up percentage uncertainties here? It will be the power. So for example, if we have X is equals to 3A to the power of 2 divided by square root of B. A square is, you can think of it as A times A, right? As for square root of B, you can think of it as B to the power of negative half, isn't it? So because of this, the percentage uncertainty of X is going to be 2 times the percentage uncertainty of A plus half times of the percentage uncertainty of B. Alright, so this is a summary of the rules regarding evaluating of the resultant uncertainty. So if you're summing up terms, you sum up the absolute uncertainties, and the coefficients scale up the absolute uncertainties. On the other hand, if you are doing a multiplication of terms, you should be summing up the percentage uncertainties. And you should ignore the coefficient. It's the power that becomes the scaling factor. Alright, that's all. Ta-ta!